Okay, so we're going to show you another method for finding an inverse. We are going to be doing it for a 2 by 2, and we're doing this by augmenting with the identity, which I'll show you what that means. Now, if we had had time to do all of Chapter 7, you would have gotten more experience with these other, there are 2 other methods that we're not covering. And so you'd have a little more experience with augmenting, but I'm going to show you the steps, and we're going to use that for a 2 by 2, and then later we'll use it for a 3 by 3. But it's based on row, what are called row operations. And you might have to squeeze this in someplace on your note page, but there are basically 3 things you can do with a matrix. You can, I'll say an augmented matrix, which you don't know what that is yet, but I'm going to show you. You can switch rows. You can multiply a row by a real number, not 0, by a non-zero number. And then you can multiply a row and add it to another row. Now this all comes from when we have a system of equations. Remember when we have 2x plus 3y equals 7 and 4x minus 3y, I don't want to make it minus 3y, that might confuse you. We'll say minus 5y equals 9. You have something like that. Well, we know how to solve that because we did that in 7.1. And does it really matter which equation you write first? No. So you can switch the rows. That's not a problem. And then, can I multiply any row by a non-zero number? Yeah, we did that so that we could, get things to, combine and stuff. So yeah, you can multiply. Like I could multiply by 5 here, and I could multiply by 3 here, and I can multiply the whole row, and it's not going to change anything. Now, the tricky one is when we multiply and add. So let's say we multiply this top row by 10x plus 15y equals 35, and then we're going to multiply this bottom row and add it to the top row. Okay, so you can do that. 12x minus 15y, this is how we normally would write it, 27, but when we add them, the y's drop out, you get 22x equals, what, 62? Okay, so this is like a new row plus 0, right? You have a 0 in there. So that's the tricky one. The other 2, I think these probably will make sense. It doesn't matter which row you write first. These are representing equations. It doesn't matter if you multiply an equation by a non-zero number, but the multiplying and adding, that's a little tricky. Okay, but I'm going to show you how to do it. So, and those are the only row operations we have. They're called the elementary row operations, and just those 3. Okay, so now we have to talk about augmenting the matrix. So I'm going to take my matrix A, 2, 1, 5, 3, and I'm going to write a line there, okay? Now, that's when we say, hey, this is going to be an augmented matrix. So we're putting that line there. Next to it, I'm going to write the identity. Okay? Now, the goal is to get this part on the left to look like the identity. When we do that, the inverse is going to pop up over here. Okay? So right now, this part to the left of the line, that does not look like the identity, but that's the goal. Okay? So I usually use a very straightforward, always the same approach. Other people do things differently. In the book, they show it a little bit different, and they switch the rows, and then they do a multiplying and add thing. But the goal is I want to get, let's see, I want to get this right here to be a 1. Now I always start in the top corner, the top left corner. That will save you the most heartache, okay, if you go in the same order. Now how can I get 2 to be a 1? Well, I could multiply the whole row by 1/2. So that's what I'm going to do. So I'm distributing here all the way across. So I get 1/2 times 2 is 1. 1/2 times 1, 1/2 times 1, and then 1/2 times 0. Now, I do get some fractions. It's very common to have fractions with inverses. So I'm not going to let that bother me. I'm just going to live with the fractions. 1/2, if I have to have a fraction, 1/2 is a pretty good one to have. The second row, I'm just going to copy it down. Okay, so I'm going to give you a little hint. When you want a 1, multiply the whole row by, you know, what you need to, the inverse of the number, right? Like I said 2, and I multiplied by 1/2, right? Okay, so this is elementary row operation number 2. You're just multiplying a whole row, okay? All right, now I want to get, and this is how I always do it, I work in columns. So I got the 1, yay. Now I want this 5 right here. I want that to be a 0. More than anything, I want that to be a 0 because I'm trying to get the identity on the left. So I'm going to use step 3, the operation 3. Okay, so when you want a 0, multiply and add. Okay, so what I'm going to do is I'm going to multiply the top equation by -5, and then I'm going to add it to the bottom equation. The bottom equation is going to change. The top equation is not going to change. I worked hard to get that 1 there. Okay, but now I'm going to do 2 things at once. It's like walking and chewing gum at the same time. I'm going to multiply by -5 and add it to 5. That's going to give me 0. And then I'm going to, now you could go over to the side and say, okay, I don't want to do all this in my head, so let me just multiply -5, -5 over 2, -5 over 2, 0. Whoops, I don't really want that line there because I'm not doing the matrix exactly. I don't know, maybe the line helps. Just going to erase a little bit of the line. Okay, but then we're going to add it to that bottom row. So 5, 3, 0, 1. Okay? And then what do I get? Well, 0. Now that's -2.5 and 3, that's going to be 1/2. -5 halves and 1. Okay? That's what I'm going to put then right here. Okay. So this is the multiplying and adding. Now you might be saying, why didn't you change the top row? Why didn't you multiply it by -5? It's just temporary. We're only doing it to get a new second row. Okay. So that's why, because we don't want to lose our 1, right? All right. So it's like you temporarily multiply it and add it to the other row. You get a new row. It's the bottom row, though, that you're getting a new row. The top row stays the same. Okay. So don't worry. We're going to do more of this. So hopefully it'll make sense. Now, there's a couple things you could do here. If I probably would just multiply this bottom row by 2, because my next goal is to get a 1 right here. So I would just multiply by 2. This is how I would do it. You know, like I said, other people have different methods. So I'm going to copy the top row. And I do love working with matrices, but that's how I would do it. Okay. Now, I just have to do one more thing to get the identity on the left. I need to get a 0 here. Now, if you're asking me questions like, well, why didn't you just do the 1 and 0 in the first row and then the second row? Why did you do it in columns, 1, 0, and then you kind of went up, like you got the 1 in the bottom and then went up? I find it easier to get the 1s first in the column and then the 0s in the other spots. So I always do it that way. What you want to make sure is that you don't mess up the work that you've already accomplished. You want to make sure you don't lose the 1 that you already got and you don't lose the 0 that you already got. Okay? So that's why I always go in the same order. You'll see it when I do another example. Okay, so now what do I need to do? Well, to get this to be a 0, my goal is to get that to be 0, I'm going to have to multiply and add. I'm going to multiply by -1/2, and I'm going to add it to the top row. Okay, so I'm going to be replacing the top row, and I usually use arrows to show where I'm putting things. Okay, so the top row is going to stay the same. I'm just going to write it over here so you can see it. I'll make a long line. Okay, then the bottom row, -1/2 times 0, that's 0. Then I get a -1/2 here. I get a +5/2, and I get a -1 there. Okay? And then I'm going to add those together. 1, 0, 6/2, which is 3, and -1. That's going to replace the top row. So I've got 1, 0, 3, -1, and then I have 0, 1, -5, 2. Okay, so the multiplying and adding I did over here. So I multiplied the bottom row, that was in orange, and then I added it to the top row. So I'm adding it to the top row gets replaced. Okay, now I have the identity here, and that means the inverse is here. So A inverse equals 3, -1, -5, 2. You could check it by multiplying it times A, make sure we got it right. Okay. Ooh, that is a long video.